So in this video I'm going to demonstrate the interactive development capabilities and scripting capabilities of LivelyFlow Qt in more detail. I'll show a rather nerdy example that is not part of the LivelyFlow Qt system on our website. Basically, I've added some additional code to the system that allows me to script all the objects in the system easily in such a way that you can actually see in this video what is happening. And I will then show the actual code, how this is being done. So let me begin. I'll make the evaluator a little bit bigger so you can see what I'm actually doing, and I'll type in some code. World start bouncing. So the world is the reference to the object that actually holds all the objects you can see currently in the world. So it's basically a container of all the visual structures in the main world, and start bouncing is the method that I've added. And now when I evaluate this piece of code, it'll start bouncing all the objects, and they'll bounce off the boundaries of the world. And all the objects are still fully active, like for instance if I click on any of the subworld icons, I can go to the subworld. In this case it's only the main world that's being scripted, not the subworld, so only the objects that you see here in the main world are being bounced. And for instance, this dial object should still be fully active if I manage to grab it from the correct place. So anyway, you get the basic idea. So let me stop that effect now. Well, stop bouncing. And again, I'll evaluate that. So the scripting effect stopped, and now let me show how this has actually been done. So the first thing I'm going to do is I'm actually going to open the inspector tool so you can see the definition of the world, and I'll make the inspector bigger because it may not be easy to see this in YouTube. So here's the definition of the world. And you can see here it's an instance of a Qt world morph class. And one thing I should say here is that since this is implemented in Qt, all the layouts, everything works sort of out of the box basically, and you could view the details of the world instance, but anyway in this case we don't need to do that. So let's open a class browser where we can find the definition of the Qt world morph class. So here's a class browser, and for those of you who are familiar with dynamic languages such as Smalltalk, this may look somewhat familiar at least. So this is the class browser showing the classes in the system. Again, the layouts here work nicely because of the underlying Qt system. And that's where you can find the Qt world morph class that we are interested in. Here are its class methods and instance methods, and the methods are presented in chronological order, in the order in which they have been defined. So for instance, here is the let me make sure the evaluator is also visible. So that's the method we just called stop bouncing, start bouncing. Here's the code that actually creates the bouncing effect for the world, and I'll just briefly summarize what it does. So first of all, it checks if a timer has already been associated with the world, and if not, it creates a new QTimer instance. You can look at the Qt documentation for details. And then it connects the timeout functionality, the timeout signal, to a function that's also defined here, and this function invokes world bounce all. So bounce all is an additional method that I've defined here, and here's the definition of that function. So again, reading the code, it gets a list of all the morphs, submorphs in the world. That's basically all the visual objects inside the world, and then it iterates over those objects and invokes a function called step and bounce on each of them. And the step and bounce functionality has been defined in the Qt morph class. And again, you can see its methods here, and here are the stepping functions that we've added. The step and bounce function is here, and this is a call through to another function called bouncing owner bounce. And as its name says, basically we want to create a visual effect where objects are bouncing within the boundaries of the container, the owner, where they are currently located. And here, for instance, in this case, since we are inside the main world, we are getting the current world and its bounding rectangle here, and then we are bouncing inside those boundaries. And here's the definition of the actual bouncing function. And in this case, I'm going to show you the original source code. So we have mentioned earlier, in addition to using these interactive tools with Lively for Qt, you can also use conventional source code for defining the applications. And here's the bouncing functionality that we have added to the Qt Morph class. It's original source code definition. So that's the syntax for adding new methods. Here's the bouncing owner bounce method, and here's the bounce and bounce definition. And basically what happens here is that, first of all, if the object that we are currently bouncing doesn't have any velocity vector, we create one so that it knows where the object will go next. And then we're basically checking the boundaries, whether we are outside bounds or inside bounds, and then negating the velocity, horizontal velocity or vertical velocity, to keep the object within the bounds of its container, its owner. And that's how it's been done. And by looking at the source code, you could also find the changes that have been done to the world. So here's the bounce all method, the original source code definition. But anyway, let's go back. So that's basically how the code was defined. Let me invoke start bouncing again, and now since we have these tools in the world, they will of course start bouncing off the walls as well. And let's stop it again. Stop bouncing. Oops, typing error. So alright, so you get the basic idea. So the next thing I wanted to show is that in the other demos you didn't quite yet see the debugger functionality that's available inside the Qt environment. So I'll just show a simple example demonstrating that capability. So what I'm going to do now is that I'll right click the background of the world and then instantiate a push button. So here's a new Q push button. Let's make it bigger. Actually, let's scale it so you can see the text a bit bigger. And the next thing I'm going to do, I'll use the evaluator to get a reference to that button. Again, using the that pointer to basically get the reference to the object that's being clicked with the mouse last. So now I have a reference to that. And just to show that I have that pointer, let me invoke rotate on that. So my button rotate will now rotate that object. Let me show one more thing as well. So now if I want to change the text of the button, it could be done this way. My button, you need to use the inner reference to get access to the internal Q widget inside. So now when I evaluate that, the text of the button instantly changes. Now let me intentionally make a mistake here. So I'm going to get some code and paste it here. So now I'm defining a connection for the buttons pressed function and the function that I'm defining here. Basically, I'm defining a function that calls another function called garble, and that's something that doesn't exist. So when I evaluate this function, we now have created a connection between the button and the garble function. And when I actually do click on the button, what happens is that we instantly